Okay, hello everybody. Once again, welcome to our third and final video, almost final video, I should say, of chapter 2.3, Measures of Central Tendency, Mean, Median, and Mode. This is Chris Pliley once again. And so today we're going to finish off by talking about one last way that we can find a mean in particular. And what we want to do is we want to be able to find the mean given not a full set of data, but instead given just a frequency distribution associated to a data set. And so the real advantage of this is that it allows us to be able to actually explicitly calculate the mean if we don't either have access to all of the data in order to calculate the sort of true mean or arithmetic mean that we might try to find, or if we only really need an approximate mean, then this is an easy way to go about it. So to illustrate, let's think back to our best actress, best actor scenario one more time. And so we had this big list of ages. On the left we have the actresses, on the right we have the actors. And we could actually find the mean using the old-fashioned way. That is, using the formula, the mean of all of these best actors, I'm using mu because it's a population, not a sample. This is all the actors, is equal to the sum of all of these individual values. I let x be all of these numbers, 41, 40, whatever, 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 divided by the total number of data points we have, which I think was 82 or 83. And I could do that, and I could go ahead and find the mean in that manner. But instead, let's find another way that we can do it that will work even if that information is not available. So recall what we did is we sorted these two big lists of data into these two frequency distributions here on the left and the right. The ages of the actresses on the left, the actors on the right. And so what we're going to do is we're going to use just these tables to estimate the mean age of both the actors and the actresses. And so the right way to sort of think about this is what we're going to do is we're going to make an assumption. And that's going to be that I'm going to assume that all of these actresses that are between 21 and 30, of which there are actually 32, there's 32 actresses in that frequency class, I'm going to assume that every single person in here is 25.5 years old. And why did I pick 25.5? Well, just because that's the midpoint of that class. So you can see right here, to find the midpoint between 21 and 30, I sum those two ages and I divide by 2. And if you do that, it's a routine calculation and it's 25.5. Now, I don't know that this is true, and in fact, it's not true. If we look back to the original table, there's a whole bunch of different ages of actresses between 21 and 30. I can just circle a few here to illustrate, and there's others in here too. And there's a lot of them. There's 32, and I don't know exactly what that mean is. All I know is that they're all grouped into this one class. But if I assume that they all have a certain age, like 25.5, then it allows me to actually go ahead and calculate the mean. Now, I mentioned down here, if you actually go and you find all 32 names in that list and you find their mean age, it's not 25.5, it's actually 26.8. But it's relatively close, and even if it wasn't close, this is just a general method that we can use to approximate this mean. So here's what I'm going to do. This is my strategy. I'm going to take each of my frequency classes here, of which I have 1, 2, 3, 4, 5, 6. I'm going to take all of these frequency classes, and I'm going to go ahead and I'm going to calculate the midpoint of the class. And so in this case, the midpoints are easy enough to see. I don't even need to do the calculation. But remember, I just have to add the lower class limit to the upper class limit and divide by 2. And because these happen to work out nice and evenly, my midpoints are always 25.5, 35.5, and so on. And the way I'm thinking about this, my real idea here is that I'm saying that this midpoint represents the approximate age of the actresses in each of these classes. And so it gives me an estimate as to what the mean age of all of these actresses in each of these classes is. So I'm assuming that these, for instance, 3 actresses who happen to be between 51 and 60, I'm just assuming that their average age is 55.5. I'm assuming that the 2 actresses that were above 70 have an average age of about 75. And this is how I'm going to formulate my estimate for what the actual mean age of all the actresses is. And so the strategy is basically this. The strategy is to just go ahead and take a weighted mean where my data points are these midpoints right here. So I'm going to find the mean of these ages. I'm associating these midpoints to be ages, and which weight am I going to use for each of these ages? So here I have 6 points of data, 25, 35, and so on and so on. And what I'm going to do is I'm going to take each of them and I'm going to give it a weight according to the frequency. So essentially what I'm going to assume is that the first term is 25.5 times 32. And what I'm basically assuming here is I'm assuming that I have 32 actresses aged 25.5. Sort of like with our class example, where we added a weight of 20 to our females who had height 5'4", I didn't actually have 20 females that were all 5'4", and in this case I don't actually have 32 actresses that are all 25.5 years old exactly, but this still represents the actresses in this class, and it gives us a good estimation of what their full, the sum of their ages would be had I actually gone through the process of adding them all up individually. So this represents the sum of the actresses who are between 21 and 30. Similarly, the second value here represents the sum of the ages of all the actresses between 31 and 40. I multiply my next midpoint by the frequency, and so on and so on. I multiply 45.5. Basically, I take each of these, erase some of this for you. I take each of these midpoints and go ahead and multiply them straight by the frequency. And what I'm doing is I'm weighting these values according to how frequently they appear. And so what that does is it lets me take just the regular old weighted mean formula. I take the sum of the x times the w divided by the sum of the weights. And so I take 25 of weight 32, 35 with weight 32, 45 with weight 14. I add them all up, 1, 2, 3, 4, 5, 6. I divide by the sum of the weights, which is just really the total number of actresses. It's the sum of the frequencies, 32 plus 14, etc., etc. And in the end, once I punch this in on my calculator, I get my mean age for actresses right down here, 36.4. And so how do I go ahead and replicate that for the males, for the best actor winners? Well, let's see if you can do it. Okay, so what I want you to do here is try to take this frequency distribution that we have here on the left, and I want you to try to fill in the midpoints and then use this distribution to actually estimate what you think the mean age of the best actor winners is. And you can use these two steps on the right here. Your first step, of course, is to find the midpoints and fill them in. And then after that, I want you to go ahead and find that weighted mean using the midpoints as your data points and your frequency as your weight. So give that a try and see what mean age you can come up with for the actors. Okay, so hopefully you did this and you did it correctly. What we'll notice first is that I filled in the table down here. Forgive my childish handwriting, of course. I'm trying to get better with this. So first thing you do is you find the midpoints of each of these classes. Finding the midpoint is easy enough. You've done that when you did things like build frequency, histogram, so hopefully you remember. But in this case, the midpoints actually tend to be the same, or are the same, I should say, as with the actresses, of course, because our classes are the same, the midpoints are the same. So it's still 25.5, 35.5, and so on. And then I go ahead and find the weighted mean, treating the midpoint as my data value and the frequency as my weight. So the frequencies are represented in red down here in this rather lengthy computation, and the midpoints are represented in black. And so I go ahead and I multiply. And remember, the key thing is to keep the idea in your head that what I'm doing here is I'm simulating what would happen is if I were to add up all 87 or whatever it is actors' ages individually. And if I were to do that, then I would have 2 actors aged about 25. I'd have 29 actors aged about 35.5 on average, and 36 aged 45, and so on and so on. And so if you go ahead and carry out this whole calculation, then if you find the same thing as me, you should find the mean. I'll use mu because this represents our whole population of actors to be about 44.6. I've rounded off a bit. Approximately 44.6 years is what we can estimate the average age of our actors to be using this method. And so how good of an estimate is that? Well, what did we say for the females? We said that the actresses had a mean age according to our estimation using the frequency distribution of 36.4. The males had 44.6. And you can see how good these estimates actually are if we really look at the actual data. So I went ahead and calculated the actual mean age for the actors and actresses by summing up all of those 87 numbers and dividing by 87 in the original list. And look how close we were, 36.24 and 44.08. So that's how we find the mean of any frequency distribution. So remember these steps. If I'm giving you any frequency distribution at absolutely any time, you can use that to estimate the mean. So remember two things in particular, in addition to howing to do this. Remember that this is just an estimate, and you're not finding the actual mean of whatever your data set is. You're just using the distribution to come up with an estimate. But since all of statistics is more or less a game of estimation, this isn't a bad thing. Okay? And so in order to find the mean of a frequency distribution, step 1, find the midpoint of each class that you have. Step 2, multiply these midpoints with the frequencies and sum them up. And step 3, take this sum from step 2 and divide it by the sum of the frequencies. And the sum of the frequencies in a frequency distribution really just represents your sample size.